You stand in a room where something impossible is happening, and the air feels charged with a kind of quiet anticipation that makes your skin prickle. A handful of particles resting on a lab table begin to tremble, as if waking from a long nap they never asked for. At first, the motion is barely noticeable, like dust shifting under a slow breath. Then the trembling grows bolder. The grains gather with purpose, rising and reshaping themselves with the quiet swagger of matter that has finally decided to admit it has talents worth showing off. They stretch, curl, fuse, and melt into new forms that bend light in strange and hypnotic ways, each motion more confident than the last. It feels like physics is trying out a magic trick and discovering it enjoys performing. In that moment, you can sense something changing around you, a subtle signal that reality is preparing to reveal a hidden flexibility you were never meant to overlook. This is programmable matter stepping into the spotlight for the first time, and the message is crystal clear. Your future is about to expand dramatically in ways that feel strange, thrilling, and deeply personal. And the most astonishing transformation this technology unlocks is something humanity has dreamed about for generations, a shift we will return to later in this journey. That shift reaches further into your life than you might expect, because the objects surrounding you are on the edge of a transformation. Instead of adapting your routines to technology, technology is preparing to adapt to you. Walls, tools, vehicles, clothes, and even the devices you carry will soon gain the ability to reshape themselves depending on what you need in any given moment. Imagine a world where your environment responds to your intent instead of expecting you to work around its limitations. This is the moment to stay connected to breakthroughs that will influence your home, your work, your mobility, and your creative potential. So subscribe, like, and turn on notifications to keep exploring the technologies reshaping your world. The path toward this reality began in a lab at MIT, where researchers developed modular robotic cubes called M-blocks. Each cube contains a spinning flywheel that acts like a gymnast, launching into a perfectly timed vault. These cubes hop, twist, and snap together with magnetic certainty, moving with the unpredictable charm of a swarm that finally decided to collaborate after years of chaotic experimentation. Their power doesn't come from their size, but from their principle. Each cube behaves like a pixel of physical existence, capable of joining with others to form steps, tools, platforms, or supports. Picture those cubes reduced to the size of sand, each one a tiny building block ready to assemble into surfaces, structures, or objects exactly when you need them. Your desk becomes a landscape of unrealized possibility, waiting for your command. Mechanical metamaterials introduce another powerful avenue of transformation. These remarkable materials rely entirely on geometry rather than motors, folding into rigid beams, soft cushions, twisting hinges, or curved supports depending on how force moves through them. Watching one transform feels like watching physics rehearse an interpretive dance routine with surprising grace and enthusiasm. Studies published in journals such as Nature Materials reveal that these structures are robust, scalable, and more than capable of handling the demands of real-world environments where adaptability and durability must coexist. These materials do not wait to be told what to do. Their form instructs them. Then, there is the surreal realm of liquid metal. At Carnegie Mellon University, scientists manipulate droplets of gallium-based alloy using electric fields. These droplets stretch, merge, and separate, yet every shift follows strict scientific laws. When arranged into networks, they create fluid circuits and reconfigurable muscle systems. They glide and reshape with a calm confidence that makes traditional rigid machinery feel primitive. In their shimmering, flexible behavior, you begin to see matter-learning skills once reserved for more imaginative corners of fiction. All these advances converge toward an extraordinary truth. Materials themselves are becoming active participants in the world rather than passive objects waiting for instruction. Instead of building robots from individual components, the material itself becomes the robot. Each microscopic module behaves like a cell in a synthetic organism, and when billions collaborate, the resulting structure takes on a kind of intuitive responsiveness. DARPA-funded research imagines surfaces that soften when you want comfort, structural supports that strengthen during storms, and tools that quietly reshape themselves when your angle of reach becomes awkward. You begin to understand that this shift places you at the center of environments that adapt precisely because you exist within them. The greatest challenge in achieving this future lies in miniaturization. Micro-robotics labs are pushing boundaries by developing robots so small that an ant might consider them highly competent colleagues. Some of these tiny machines move through electrostatic attraction. Others rely on vibrations or microscale actuators that stretch like artificial muscles. As these components approach the scale of sand, programmable matter becomes indistinguishable from ordinary grains until the moment you give them purpose. When you witness motion at this scale, you realize you are looking at a type of matter that can pour into a pile, solidify into a structure, assemble into a tool, or disperse into nothingness on command. That flexibility forces you to reconsider the fundamental assumptions you've made about the physical world. Construction evolves into something alive. Imagine walls adjusting their thickness depending on weather, privacy needs, or energy efficiency. Envision a home reinforcing itself during an earthquake, sending material from low-stress regions into areas that need rapid support. Picture emergency shelters assembling themselves within minutes, rearranging internal space based on who enters and what they require. Buildings stop acting like silent containers and begin functioning as thoughtful partners invested in your safety and comfort. Transportation undergoes its own metamorphosis. Vehicles could transform their aerodynamic profiles mid-journey to reduce drag or increase stability. A spacecraft entering an atmosphere might alter its surface texture to manage heat more effectively, then grow extended structures once it reaches orbit. NASA's exploration into adaptive materials offers a glimpse of this potential, but programmable matter takes it much further. NASA's exploration into adaptive materials offers a glimpse of this potential, but programmable matter takes it much further. Imagine spacecraft built from dormant swarms of intelligent particles stored compactly during launch, then blooming into antennas, solar arrays, tools, and even habitats once the mission begins. Suddenly, the limits of exploration become tied not to what can be launched, but to what can be assembled. Medical tools become more considerate and capable. A diagnostic capsule built from programmable matter could change shape to navigate your body safely, reducing discomfort and improving accuracy. Surgical instruments could adapt their geometry in real time, reaching difficult areas without causing unnecessary stress. A prosthetic limb made from adaptive lattices could read your movement and adjust its support instantly. Medicine transforms into something personal, intuitive, and deeply responsive to your body's needs. Your everyday environment starts behaving like an intelligent companion. Furniture adapts to your posture. Clothing shifts insulation to match temperature changes. Devices change shape to fit your grip or your task. Rooms alter acoustics to help you rest, focus, or create. Instead of battling against uncomfortable surfaces, rigid layouts, or poorly designed tools, you begin interacting with a world that actively supports your physical and emotional well-being. As possibilities expand, discoveries accelerate, creating a moment where staying informed becomes essential. Continue exploring this frontier and subscribe, like, and turn on notifications to stay ahead of the technologies gaining momentum. Soft robotics deepens the power of programmable matter by adding sensitivity, flexibility, and healing. Some soft robots repair breaks automatically through chemical reactions. Others shift internal fluid to alter shape or stiffness with remarkable nuance. When these capabilities merge with metamaterials or modular particles, programmable matter gains an uncanny tactile intelligence. It senses weight, pressure, movement, and temperature, responding with adjustments that feel almost empathetic. This shift carries profound benefits into your life. Floors might soften in the instant before you fall. Kitchen counters could adjust height when someone new enters the room. Workspaces could transform to match your creative rhythm, offering openness for brainstorming or intimate alcoves for deep focus. Environments develop a kind of partnership with you, offering safety, comfort, and adaptive support exactly when you need them. Creativity expands dramatically when matter becomes dynamic. Sculptures could rewrite themselves over time. Stage sets could reshape to mirror the mood of a performance. Games could spill into the physical world, assembling characters, obstacles, and environments around you. Within 5 to 10 years, early consumer applications will start entering your daily routines. You might encounter adjustable surfaces, adaptive furniture, or devices that subtly reshape to suit the task at hand. Industrial adoption will arrive even sooner because the advantages in safety, efficiency, and resilience are too significant to ignore. Construction robotics, aerospace adaptables, and medical morphing tools will lead the transformation until programmable matter becomes familiar rather than futuristic. Looking farther into the future reveals something truly extraordinary. Spacecraft built from programmable matter could assemble in orbit into structures far larger than anything that could be launched from Earth. Exploration vehicles might alter their geometry to survive extreme planetary conditions. Distant missions could carry compact swarms of dormant material that expand into massive structures upon arrival. You begin to imagine starships not as rigid machines, but as living architectures built from intelligent particles responsive to their environment, finally revealing the larger promise hinted at from the very beginning. Everything leads back to that first moment on the lab table, where a few trembling grains hinted at a world ready to shift. Programmable matter transforms objects from static possessions into responsive collaborators. It changes your surroundings from rigid frameworks into supportive, adaptive systems. It turns imagination into something sculptable in real time. Once matter learns to move, build, heal, and reshape itself, your relationship with the physical world evolves from using tools to co-creating with them. The breakthroughs racing towards you will redefine how you live, work, create, and explore. Keep moving with this transformation and subscribe, like, and turn on notifications to keep exploring the technologies reshaping your world. This is Tech Mythos.